something that isn't really a layout, but indirectly related to layouts and especially responsiveness of our apps and layouts, are so-called window size classes. That is a concept that we can include in our Compose project with this adaptive Android dependency. So just make sure to add the same. Again, this is of course included in the link to GitHub below, Android X Compose Material 3 Adaptive, and then make sure to add this here in your build.gradle file with this line, and then we can try around with that to see what window size classes are actually all about. So I think taking a look at the Android docs makes this the clearest, because all we need to do is we need to take a look at this graphic and understand which different window size classes there are. So as the name says, a window size class refers to a specific size of a window, and we have these different classes, so compact, medium, and expanded. So depending on how wide our device is in a specific orientation, that is also important, depending on that, a different window size class will be assigned. Different window width size class, if we're talking about the width. So for example, we have the compact size class, which is for screens that are not really wide. So just like our mobile devices, then if we have a tablet device, which is a little bit wider, it gets assigned the medium window size class. And we have an expanded size class, which is mostly used for desktops, or if we maybe have a tablet in landscape orientation. Because of course, if we rotate our screen, then it has a different width, and therefore it might also get a different window width size class. But if there are window width size classes, there are also window height size classes, like here, which then obviously refer to the current height of our screen. So for example, we have a compact size class here if our phone is in landscape mode, because then it's not really high. A medium height class if we have a phone in portrait mode, because these have a certain height, same as a tablet in landscape mode, or an expanded class again if we have a tablet in portrait mode, so the highest possible device type. But it's important to understand that these different classes don't strictly refer to device types. These are easily used as examples here, but in the end, they just refer to the actual width and specific thresholds, a width or the height value of the device has to surpass to jump into the next class. So you can see if the width of our current screen is at least 600 dp, then the medium size class will be assigned for the width. And if it's more than 840 dp, the expanded one will be assigned. So that's really the only metric that matters here for these window size classes. But what these window size classes now allow us to do, of course, is to build responsive layouts where the actual layout might look completely different for a larger device than for a smaller device. So you've already learned about building responsive layouts here by just making use of things like dynamic units, of making use of weights, of using the right arrangements for a row or a column. All that already helps a lot with making a layout responsive. But what this can do is, if you, for example, have a simple list screen here on phones, but on larger screens, you actually want to have a completely new composable here on the screen. For example, some kind of navigation drawer or some kind of side menu that is always visible, which would be way too much to show for a small device, but on a larger device, there's actually enough space for us to show that. So we can make use of these window size classes in code to check, okay, are we actually on a compact screen width device? Then please just show this list composable. If we are on an expanded device, then there's actually enough space to also show the sidebar. So if the actual composition, the actual compose hierarchy looks different depending on the screen width, then make use of window size classes. So let's take a look at how this looks like in code. I've prepared a little sample composable here again, and we can get the current window class by calling current window adaptive info, which is a composable function that retrieves this window adaptive info, and then refer to the window size class. We can then also build and refresh here so we see the preview. And then what we could do is we could have a when expression here. Depending on the window class, that window width size class or height size class, depending on what we want to refer to here. So if we want to check if there is enough width to fit a certain extra component in, we rather want to check the width size class here. And this can be either window size class.compact. It could be window size class.medium, as we've seen. And lastly, you guessed it already, window width size class.expanded. And if we now just put in maybe a text composable in here that says compact, here we say medium, and here expanded. Medium, expanded. And you can see on the preview here, we are apparently dealing with a compact screen width. What we could now do is we could say we annotate this preview with preview screen sizes to get lots of previews here with different screen sizes. For some reason, I don't know if this is a bug here in Android Studio, but for some reason, this isn't really working here. You can see this should be a desktop preview, but it's actually a phone preview. It's really only working for the landscape preview. And you can also see that the text now overlaps with our status bar. You've already learned how we can fix this. So let's take our composable code and put it inside of a scaffold. Scaffold here, move this when expression in the scaffold, and then we get this inner padding value we can apply to some kind of root layout like a box here. Modifier padding, let's say fill max size, and then padding of inner padding. Oops, inner padding. And then we just move our when expression in this box. If you then take a look, then this should be fixed after the preview has been reloaded. Yes, there is. So you can see on the phone landscape variant, we have a lot of width available. So it says expanded for the window size. And on the smaller sizes, it says compact. So this should actually be desktop, as I said, and this one tablet, which for some reason isn't working. This seems to be a bug, but normally you would see the different screen sizes here. But we could also manually actually change this by removing this preview screen sizes annotation, and rather extend this preview annotation we have here by assigning a specific width dp value that we want the preview to have. For example, 1000, so really large. Okay, you can see it still says compact, even though the width here is quite wide, 1000 dp, which should make this an expanded screen size. But apparently we also need to assign a device here. So the device the preview is running on, which you can set to devices Nexus 10, for example, which is a 10-inch tablet. So this should definitely be expanded. And then you can also see that we get this expanded. What I'm not sure is if we change this width now to something like 700, that should be medium, and we reload the preview. No, okay. It seems like the window size class is then entirely created based on the device type as well. Or at least the preview screen width has no impact on that. So we can also remove this. That was also new to me. But if we choose something like maybe a smaller tablet, Nexus 7 maybe, then you can see now we get the medium size class. So that is a 7-inch tablet. And here we would then show this medium text. But the interesting part now, of course, starts if we have actual differing layouts depending on the window size class, as I said. So rather than just showing a different text, that is not something we need to do here. But let's say if we are on a compact screen, we would simply show a normal list, lazy here column, it's actually called, with some items. We say 40 items, maybe. Just some texts where we say the text is item it. Maybe give these texts some padding with a modifier, the padding 16 dp. I'll enter to import dp. And we could actually then also extract this. First of all, give it a modifier to fill the whole size, but we could then extract this into a separate composable. So we can reuse this, of course, across different screen types here. So we go down here, we would create a composable function, my lazy list, for example, paste this in there, make sure to actually refer to the modifier we've passed in here. So we could also flexibly change the modifier from the outset as well to add more configuration to this lazy column. But we could then go to our compact screen size and say we want to have our lazy list, my lazy list in here, which right now does not show because we are on a medium-sized screen. And we only show this for the compact screen. We might also want to show this maybe on a medium-sized screen. This is something we would need to experiment with, how this looks like. So if we zoom out a little bit and then actually also replace this with my lazy list here, then also on this screen you will see that we have our lazy list. However, if we're on an expanded screen with a really large width, then maybe we want to show some sort of side panel in addition to this lazy list. So what we could do is we could have a row in here and say, okay, modifier, this modifier fill max size, and we maybe just simulate some sort of side panel here with a column. So we say we have a column, give it a modifier of modifier dot fill max height. So we just fill the whole height of our screen. But we can say we get it we give it a weight of maybe 3f. So we want to have 30% of our rows width be occupied by our simulated side panel here. And we can then say background is something like color red. So we just visually highlight it. And in here we have, I don't know, some menu options or so. So maybe a text for menu option 1, menu option 2, and 3. And then next to that column, we simply use our lazy list again. So our my lazy list composable, give this one a modifier now with fill max height, but a weight of 7f, so 70%. So our lazy list gets 70% of the screen width of the rows width, and our side panel gets 30%. And if we now actually change the preview back to an extended screen to be able to see that, Nexus 10, And then take a look, then you can see that's exactly what we now get. So we get a different layout for large screen devices. We have our different menu options here for our side panel, which takes exactly 30% of the screen's width. And then we have our list in here. So this is really something you need to do if you need to make your layout responsive in a way that you add more UI components just for certain screen sizes, for certain screen dimensions, then you need to make use of these window size classes. But as I already said in an earlier video, really most of the responsiveness that you can give an app is done with these relative units, with properly using weights, with using arrangements correctly, with using the right layouts like a box, column, row, flow column. You've already learned about all that. These are really the core, and properly using them is the core of making your app responsive. But sometimes you just have these requirements that on a certain screen size, you could just switch to a different type of layout, and then you need to conditionally show that layout. For example, with such a when expression that shows UI A for medium and compact screens and UI B for an expanded screen.